Hello, my name is Gwendolyn Gettliffe. I'm a PhD candidate in the MIT Space Systems Laboratory working with Professor David Miller on MAJESTIC. MAJESTIC stands for Magnetically Enabled Structures Using Interacting Coils. So our NIAC project is looking at using electromagnets such as those used in MRI machines or other large magnetic equipment to generate magnetic fields and move parts of spacecraft around with respect to each other. So they can deploy, they can support each other, they can move around in space with respect to each other, and it's propellant-free, which leads to longer lifetimes for spacecraft in space. So from day one, we were working on sort of the concept behind the mission. What could we use this for? What missions, like large telescopes with really big structures, with really big antennas, what could we actually use these magnets for? And from that, we've worked on modeling and simulating the deployment of these coils and actually seeing whether or not, when we make them magnets, whether or not they actually move with respect to each other. And then from there, we've actually started looking at hardware and building it in lab demonstration. So the next steps in our project are actual demonstrations of this technology in orbit or on parabolic flights or in environments that don't have the gravitational conditions we have here. Magnets are currently used for levitation and roller coasters, for trains, and so developing more advanced cryogenic cooling systems for superconducting magnets expands the use of systems like these. One of the major advantages of this technology is that it's lower mass than building a large telescope out of just aluminum and traditional structural parts. And also we're looking at ways that we can sort of wad up a superconducting coil into a ball like twine, and when you run current through it, have it expand into a larger structure than could ever be carried into space. So one of the major flagship missions that's going on right now is the James Webb Space Telescope, and it has a lot of unique technology development, like a big sun shield to keep its optics cold. And a sun shield is a really good case study for us because it both has unfolding of layers, of separation of those layers apart from each other, expanding and tensioning them, and in general, you are developing a cryogenic atmosphere there that you can utilize to cool your superconductor at the same time as you're cooling your telescope, so you get sort of a double whammy of use there. And so looking at deploying large sun shields is a really compelling case study for us. I would say the community that NIAC builds has been incredibly beneficial to us. We've talked to people who are working on large membranous mirrors, such as Joe Ritter. We've talked to Shane Westover and the NASA Johnson crew who are working on superconducting magnets for radiation protection. I mean, the conversations we have with these people, and we're able to sort of use some of their data to support our research and vice versa. And we built a community that we talk to each other all the time, and we wouldn't have met each other otherwise.